Read the first word and obey it. It says areas, not radii, so the very first thing on your page should be 3 areas. Area is pi r squared, so square each radius. 18 squared is 324. 6 root 3 all squared. Square the 6 and square the root 3 separately. 36 times 3, 108. And 6 squared is 36. Keep the pi in every one of them. It is going to cancel, and it costs you nothing to carry. Now test whether it is geometric, which means dividing each term by the one before it. 108 pi over 324 pi. The pi cancels, and 108 over 324 is a third. Do it again. 36 pi over 108 pi, also a third. 2 divisions, not 1. One ratio on its own tells you nothing, because any 2 numbers have a ratio. It is the second one agreeing that makes it a sequence. So the ratio is a constant third, which makes it geometric. But the question asked for 2 things, not 1, converging as well. A geometric sequence converges exactly when its ratio lies strictly between -1 and 1, and a third does. So write both sentences down, because they are 2 different marks. And here is where this part is lost. Work with the radii instead of the areas, and you get 1 over root 3, which is a real ratio of a real sequence, just not the one you were asked about. The guideline gives that 1 mark out of 3. Counting the circles means counting the terms, and you can count them with the radii. This part does not care about areas. The radii are geometric too. 6 root 3 over 18 is 1 over root 3. So A is 18, R is 1 over root 3. And the term you are looking for is the innermost radius, 2/3. Put the known last term on the left and the general term on the right, and the only thing you do not know is n. Divide both sides by 18 to get the power on its own. 2/3 divided by 18 is 2 over 54, which is 1 over 27. Notice what that is. 27 is 3 cubed. The numbers in this question were chosen so that everything is a power of 3, and spotting that is what turns the next line from a calculator problem into a one-liner. Write both sides as powers of 3. 1 over 27 is 3 to the minus 3. 1 over root 3 is 3 to the minus a half, so raising it to the n minus 1 gives 3 to the power minus n minus 1 over 2. Same base on both sides, so the exponents must be equal. Minus and minus 1 over 2 equals minus 3, which is in minus 1 equals 6. So n is 7. 7 circles, and you can check it in one line. 18 times 1 over root 3 to the 6th is 18 over 27, which is 2/3, exactly the radius you were given. Now the warning, and it is printed in the marking guideline. Answer only, 0 marks. 7 on its own, with nothing above it, scores nothing at all out of 4. Every line you just watched is where the marks actually are. Do not look at this as one complicated thing. Look inside the brackets. The first numbers are 1, 5, 9, 13, going up in 4s. The second numbers are 2, 6, 10, 14, also going up in 4s. 2 arithmetic sequences traveling together, and if you can write a formula for each, you can write the bracket. Start with the first. A is 1, D is 4, so Tn is 1 plus n minus 1 times 4. Multiply out. 1 plus 4, n minus 4, and 1 minus 4 is minus 3, so the first factor is 4n minus 3. Test it before you go on, because it costs 2 seconds. N equals 1 gives 1, n equals 2 gives 5, n equals 3 gives 9. That is the sequence, so the formula is right. Now, how many brackets are there? The last bracket starts with 81. So set 4n minus 3 equal to 81. 4n is 84, so n is 21. 21 brackets. That number is the one that goes on top of the sigma sign, and there's no way to guess it. You have to solve for it. The second factor you get for free. Look at the pairs. 1 and 2, 5 and 6, 9 and 10, 81 and 82. Every second number is one more than the first number beside it. So take 4n minus 3 and add 1, and you get 4n minus 2. There is no need to work out A and D all over again for a sequence you can read off the one you already have. Now assemble it. Underneath the sigma goes n equals 1, because the first bracket is the n equals 1 case. On top goes 21, the number of brackets, and beside it goes the bracket itself with n in it, 4n minus 3 times 4n minus 2. That is the answer. The question tells you it is not necessary to calculate the value of the series, so do not. You would be spending a minute of the exam on marks that are not there. 2 facts, 2 unknowns, so this is simultaneous equations wearing a sequence's costume. Take the simpler fact first. Sum to infinity is a over 1 minus r, and you are told that equals 1. Multiply up, and it equals 1 minus r. That single line is what the whole question turns on, because it lets you get rid of a completely. Now the second fact. Square every term of the original series, and you get a squared r squared, a squared r to the 4th. That is still geometric. First term is squared, and the ratio is r squared, not r. So its sum to infinity is a squared over 1 minus r squared, and that equals 5/6. Cross multiply, and you have 6 squared equals 5 minus 5r squared. Substitute. 6 times 1 minus r all squared equals 5 minus 5r squared. Expand the bracket properly. 1 minus 2r plus r squared. So the left is 6 minus 12r plus 6r squared. Bring everything over. 6r squared plus 5r squared is 11r squared minus 12r, and 6 minus 5 is 1. 11r squared minus 12r plus 1 equals 0. It factorizes 11r minus 1 times r minus 1. Check the middle term if you like. Minus 11r minus r is minus 12rr, which is what we want. So r is 11th or r is 1. And you must go through the quadratic to see both. There is a shortcut here that cancels 1 minus r early and lands on 11th in 2 lines. But it quietly throws the second root away, and the second root is where a mark is. Now reject one of them and say why. A series only has a sum to infinity when the ratio is strictly between minus 1 and 1. Otherwise, the terms never shrink and the total runs away. R equals 1 fails that immediately. Every term would be the same size forever. So R is a 11th. Check it if you want. A is 1 minus a 11th, 10 11ths, and 10 11ths over 10 11ths is 1. The squares give 100 over 121, over 120 over 121, which is 5/6. Both facts hold.
16 marks, and look at where the guideline actually puts them. 3.1.1 is worth 3, and 2 of those are for saying the obvious out loud, the value of the ratio, and that it lies between minus 1 and 1. 3.1.2 is worth 4, and the guideline prints, in bold, that an answer on its own scores 0. 3.3 is worth 5, and one of those is for rejecting ER equals 1. Notice the pattern across the whole question. Almost none of these marks are for cleverness. They are for writing down the sentence you were already thinking. The candidates who lose them are not the ones who cannot do it, They are the ones who did it in their head.